Okay, so this video is another solving applied mass percent problem, and it looks like it's concerning a carbohydrate. So it says the name carbohydrate comes from the fact that many simple sugars have chemical formulas that look like water has simply been added to carbon. So what you'll see is things like this. You'll see that you'll have a certain number of carbon atoms, and then you'll have hydrogen and oxygen always present in a 2-to-1 ratio. So it looks like you've got some carbon atoms to which a bunch of water molecules have been added. So a good example of this is the example they give here, which is sucrose, this one here. So it's C12 and then H2O 11 times. So hopefully you can see that the hydrogen and the oxygen are in this 2-to-1 ratio. So it looks like water has been added. Now this isn't, it's more complicated than this. All right. So, but that's how the formulas appear. Okay, so carbohydrate, right? Makes sense, doesn't it? All right. So then it goes on, it says the actual chemical structure of carbohydrates doesn't look anything like water molecules bound to carbon atoms, but it is nevertheless possible to chemically extract all the hydrogen and oxygen from many simple carbohydrates as water, leaving only carbon behind. If you search the internet for reaction of sulfuric acid and sugar, you will find some impressive videos of this. This is true. So you take a beaker of sugar and you pour in sulfuric acid, and it goes wild and crazy and it turns black and a whole bunch of steam comes off, and what you end up left with is just a plain old, so you start with sugar, what you end up with is just basically carbon. It just turns all black and a whole bunch of steam comes off, so it looks like water left. All right, none of that helps you solve the problem. It says, suppose you have 200 grams of ordinary table sugar, which is called sucrose, which has the chemical formula C12H22O11. Calculate the maximum mass of water you could theoretically extract. So we've got C12H2O times by 11. So what we're going to do is we're going to calculate the mass percent water. So kind of like how we were calculating the mass percent of an atom previously. So what we're going to do is we're going to take the number of waters, which will be 11, times that by the mass of water, which we can calculate that the molar mass of water is about 18.02. And then we're going to divide that by the mass of the sucrose of the whole compound, and then we'll times it by 100. And that'll give us the mass percent water. And of course, the mass percent water is just the grams of water that are in 100 grams of sucrose. And then once we've got that, we'll be able to use that as a conversion factor. All right, so let's go ahead and calculate our percent water in our sample. So the number of water molecules in sucrose is 11, and the mass of 1H2O, you get 2 times 1.01 plus 16.00. So that's the mass of a water molecule. And then we've got to divide that by the mass of sucrose. So we've got 12 carbons. They each have a mass of 12.01. And then we've got 22 hydrogens, 22 times 1.01. And we've got 11 oxygens. So there's all of that. And then, of course, we want to multiply it by 100. There it is. So the percent water by mass in this carbohydrate sucrose ends up being, just have to wait for me to enter everything into the calculator. Now you want to make sure you get that entire bottom line in parentheses or your math will go very wrong. Now, your percentage should be less than 100. So you kind of know if you've got it wrong if you get a number bigger than 100. So it ends up being 57.9015% water. So what do we know that a percentage means? This is grams of water for every 100 grams of sucrose, which of course we can also write as 100 grams of sucrose for every 57.9015 grams of water. So one of these conversion factors, we're going to need to solve the problem. And the problem we're saying, if you had, we'll go back and have a look at it, if you had 200 grams of sucrose, right, how much water do you have? So we've got 200 grams of sucrose is what we're starting with, and we want to end up with grams of water. So we have to multiply by the conversion factor that's got grams of water on the top line and grams of sucrose on the bottom. So then they're going to cancel out, right? So let's see what one we're going to pick. We got this guy, grams of water per grams of, it's going to be this one, right? Okay, we want grams of sucrose on the bottom line. So 200 grams of sucrose times 57.9015 grams of water for every 100 grams of sucrose. Then that cancels out, and the only thing that's left is grams of water. So just got to do times 200. And so I ended up with 116 grams of water. All right. Now it's 57% water, so more than half of it is water. So that makes sense that more than half of my 200 grams would be water. So the general strategy with this is you have to calculate the mass percent of a certain thing in your compound, and then you're going to use that mass percent as a conversion factor. Okay. Good luck with solving these problems.